Right, this is the supplemental video for chapter 2. Today, I'm going to show you some pro tips on math. So you learn the subjects from each section, and then some people said they run into difficulty when they see several different problems. That's why I'm here to guide you. All right, first of all, example 1, add two polynomials. Right, the key to solve the problem well is to understand the language of math. Again, you can think about learning math as learning a different language, like Spanish, with a certain grammar, certain root of language. I believe this is the way, one of the ways to make math intimidating. Just treat it as a different language. And then if you have to learn a language, you have to be persistent and then keep practicing until you master it, right? So let's see, add two polynomials. So add two polynomials, and then that wording is straightforward. There's always a task for you to see exactly what to do. So you just have to add up all the terms, combine the like terms until you approach the right answer. All right, we can rewrite the equation. We have 10 to the x4 to the 4 plus 8 times x3 plus 7x. All right, so when you have a negative sign between two portions, then you got to recall what to do, right? You have to distribute a negative sign. That means you flip the signs for the latter four terms. So you ends up having plus 4x to the 4 minus 3x to the 3 minus 7. That's how things work mathematically, right? And then eventually you can add the like terms, which is 14 times x to the 4 plus 8 x cubed minus 3x cubed gives you 5x cubed, right? And then we have 7x and 7. Can we add them up? No, because they are unlike terms, right? 7x should be on its own, and then the number 7 should be on its own as well. All right, problem solved. When you see a task, there's always a right way to complete the task. And let's check out another one. Multiply and simplify completely. All right, multiply. That means we have to multiply one term to others. And then when we simplify, that means we have to rewrite the expression until it looks the simplest. Okay. All right, so what technique do we learn when we have two binomials multiplied? Well, it's called the FOIL method, right? So when you see this expression, then you have to immediately recall that the FOIL method applies. And then the way for you to master that skill is to practice, practice, and practice, right? F stands for first. O stands for outside. How about I? I stands for inside. Yes, and then L stands for last. That is the most common and the most convenient way to multiply, so that we have 2x squared, the F term, plus 24x, the O term, minus 11x, the I term. And then we have negative 11 times 12. And then that will give you negative 121. That can be calculated by using a calculator, since a handheld calculator is allowed on the test, right? All right. So that's what we have. That's what we expand. And then is that expression simplified? Well, I don't think so. Why is that? Because there are like terms remains. 24x and negative 11x. We have to add them up. So 24 minus 11 gives you 13. So the term with x should be 13x. And then the last one is 120, negative 121. Problem solved. Right. So again, the key is to read a question and see exactly what we should do. Let's try the next one. Evaluate negative x to the 3 minus 3y squared when x equals to negative 3 and y equals to 2. All right, the key for this time is to solve for the expression. Right, we have to, so evaluate means calculate in math. That's the language, the root of language we should all understand. All right. In the language of math, a word can be defined differently. That's why we have to get familiar with them. So what do? We plug in x and y on the expression. All right, and then in the meantime, make sure you're not tricked by the negative sign. Right, when we plug in x as negative 3, we make sure the negative 3 stays there inside the parentheses, okay? Right, that's always the way for me to make sure I'm not messing up the signs. And then you do the same thing for y, and you'll have 2 squared. All right, a question for you. Negative 3 to the power of 3, what does it equal to? That's negative 27. And then 2 to the 2 equals to 4. So we have 3 times 4. Right. This is where we distribute the negative sign. We do that for the numbers in the parentheses that we know we can flip the sign. So we have 27 minus 3 times 4, which equals to 12. And then the final answer is 15. Right. You can definitely use a calculator when you reach that step, but I do suggest you practice calculating on your own if the numbers are simple enough. If the given numbers are simple enough, they'll help you improve as well. All right, so in case you're not getting the part with negative 27, then I can give you more tips. So when we have something to the 3, that means we multiplied that number 3 times, right? To break it down, this is how it looks. Negative 3 times negative 3 times negative 3. So negative 3 times negative 3 equals to positive 9 because the signs canceled, and then 9 times negative 3 indeed gives you negative 27. So that's why the negative sign remains when we have the odd power. And if we have even power, then the answer will be positive. And then you can use the same trick. You can multiply them step by step or do it with the way you prefer, and then you're guaranteed to get the answer as positive 81. So there's always a rule about a sign, and I'm explaining it to see why it is the case. I hope that helps. Next, solve the equation for the given variable. All right, now we have the keyword solve. Right, that's another word we should be familiar with. And let's keep reading. If your answer is a fraction, write it in reduced fractional form. So that means you have to show your answer just like 2/5, or right. That is the reduced fraction, right? Let me write it again. 2/5 is an example. And then you can also put down something like 3/10, right? These are the examples of the reduced fractions. And then if you have something like 4/6, then is that a reduced fraction? Well, it's not, because the two numbers can be both divided by something to be simplified. Okay, so we divide both numbers by 2, and then, right, your instructor probably shows you the method differently, right? So we're multiplying the fraction, an updated fraction as 1/2 over 1/2, right there. It works because the fraction I highlight right there, that fraction is equivalent to the 1. So you have a fraction 4/6 times 1, then you're still getting 4/6, right? That's why the method works here. The 1 can turn into number over number, same number over same number, which gives you the equivalent result. But the reason we're doing this is that, right, we are dividing out 4 and 6 so that we ends up getting 2 and 3. So that's how you get, this is the right example of the reduced fractional form, right? If you find a common factor to reduce a fraction, you have to work on it in this way. Okay, all right, let's do it. Solve, what does it mean? Solve means you have to figure out what x is. What is the value of the variable like x? That's what the word solve means in this context, right? Well, it's not like solve a problem. Well, that word solve sounds vague because you have to have a context to see what solve actually means, right? Okay, so what do? Right, we have to simplify the expression given because we have factor times the first term and another factor times the second term in the parentheses. And then we have to, right, so the key is to isolate x as much as you can until you get a final answer. And let me separate these two sections. Isolate x as much as you can, right? So, for example, make the x terms show up on one side of the equation. Well, let's expand two terms. We have 24x times 4 when we expand the left-hand side. And if we expand the right-hand side, you have 10x minus 2, right? So it's pretty straightforward so far, right? All right, now we have to think about how to isolate x. So it means we have two sides of the equation, and we have to make sure one side has the x terms disappeared, right? And then the simplest way is to subtract the equation by 10x on both sides. Why does it work? Because mathematically it will be correct. If you have the x with a number to plug in, and then, right, if you minus both sides by a value, then your result will still be correct. And then let me give you an example before I come back. Right, in case you're not understanding why this works, then I can show you. let's say we have 3 plus 5 equals to 3 minus 5 plus 10. All right. So let's say I subtract the both hand. Right, this is the right equation. And then if I subtract both sides by 3, then what do I get? I have 5 equals to negative 5 plus 10. Then that equation is still valid because negative 5 equals to plus 10 equals to 5. That's why this technique works. Okay. Right. The operation has to work in this way for addition and subtraction. So eventually we have 14x plus 4 equals to negative 2 because these two terms are canceled. Right. And what do we do next? Well, we're almost isolating x. Next step is to subtract the equation by 4. By 4, yes. And then in that case, we'll have 14x because these two numbers are canceled. And then we have negative 2 minus negative 4, negative 2 plus negative 4, which gives you negative 6. So we're adding the first line and the second line. We isolate the x term, but we haven't isolated x itself. And the last step is to indeed divide the equation by 14. By the way, when you divide, make sure you divide the entire left-hand side and right-hand side. Otherwise, it won't work mathematically. I mean, things won't make sense mathematically. All right. So we have x equals to negative 6 over 14. That's not the final answer yet because I do realize that there is a common factor to be divided, and then that common factor would be 2. So we have the final answer, negative 3 over 7. Problem solved. All right, that is the entire example. All right, last question, last example. So the following expression, this is, now let's go over it in the application in finance. The following expression gives an appropriate value of the total average credit card debt in a US household T years after 1995. So again, that T is a variable and then that is a number we're trying to figure out. All right. So this is the function. Yes, we're having a problem of function. The function is showing you that your calculated result depends on the T you plug in. If T equals to 1, you plug it in, then you can find exactly the credit card debt in 1 year. And if T equals to 2, then you plug in 2, then you can find the national debt in 2 years in average. All right. Use this expression to predict the total average credit card debt was or will be in the year 2006. Right. And to be honest, I'm not sure if this data is made up or not, but it doesn't matter. We're solving a problem. The key is to understand how to solve a problem. All right. So we got to fill in the blank, and then here's a hint. The key here is to keep in mind that T is years since 1995, not the actual year. So that means we have to find how many years it'll elapse from 1995 to 2006. So that's the mathematical reasoning we should work on. So that means, hey, we should, that means, hey, we're not supposed to let T be 1995. That's not the right info for the variable. What we should do instead is to find the difference, right? From 206 from 1995 to 206. If we can find the difference, then we'll get the right info. And that means t equals to 11. We're plugging in 11 years. Okay. Let's continue. For t plus 5,520. And then that function will show you that, hey, you're plugging in 11, and then you're using your calculator. So, right, it's too tough to calculate this one by hand. So that's why, again, a handheld calculator is allowed. And then we'll find that right, the national debt within 11 years is $9,854. You can put down $sign if you want. Right, so that's how you evaluate a result from a function. There's always an independent variable for you to plug in for finding the result. And this is normally the function people made up to estimate the future debt. If that's not always going to be accurate, because there are tons of factors that alter the debt from your estimation. So that's why we have to keep fixing the function in our model until we get the right info. And make sure the info is accurate enough. All right, so this is how we solve the problem. Mathematical reasoning is the key, and then knowing the language of math is the key too. Make sure you practice more problems in your homework, and then I'll see you next time.